This video we're talking about static electricity and it's something that you're probably somewhat familiar with and have day-to-day experiences of static making your hair stick up, seeing lightning obviously. So we're just going to learn a little bit about properties of static electricity, so that'll help kind of understand some of the concepts of current electricity, which is what we really want to get into. So first, in order to understand the structure or the static electricity, you have to understand matter. So I'm sure you've talked about this in previous courses about how matter is made up out of atoms. Atoms have your protons and neutrons in the nucleus in the center, and then the cloud of electrons on the outside. And so it's important to realize that electrons are negative. Okay, they have minuses on them, but they're hard to see. And since electrons are on the outside, when things become charged, it's the electrons either being stripped off or new ones being added in is what's going to change the charge of things. Because you can't strip off protons. They're way down locked in the nucleus by very strong forces. Okay. So what causes an object to be charged? So we've seen in class we can rub a balloon on our head and it becomes charged. All of a sudden it takes on this like almost magical type quality. Okay. So what causes that to be true? Well, something is charged if there's an imbalance of protons and electrons. So in a neutral atom, you have the same number of protons and electrons. If you have an entire substance where you, for whatever reason, have more electrons than protons or less electrons than protons, you are going to have charge. Okay? So if you have something that's positively charged, what it means is overall that substance has lost electrons. Not very common that it would be because it gained protons, because again protons are locked down in the nucleus. So the protons, the positives being exchanged is not what's happening, it's negatives being exchanged. So if something's negative, it means that it gained electrons. Okay? So how charged objects behave, and again we already saw this in lab, and I'm sure you already knew this or have heard of it, that we know that if you have two like charges, they're attracted to each other. Two like charges are repelled from each other, whether that's two like negatives or two like positives, and then it is opposite charges that attract one another. Okay? So again, we saw that in lab with the tapes coming together and going apart. And that's how atoms are held together, or at least how the electrons are held on the atoms, is electrons are negative and protons are positive, and that mutual attraction. Okay. We also saw in lab that neutral objects, in fact I still have balloons sitting on the back of my wall here, we'll see how long they can hold on. It depends on how dry the air is, I suppose. That neutral objects also get attracted, and so why is that? And it turns out that it's, again, remember, there's really not very many things out there that are truly neutral where they have no charges in them whatsoever, like if you have like a neutron star, I suppose. But if you have objects that have got protons and electrons in them, and yes, if we consider the bulk material neutral as the same number of positives and negatives, okay, but it still has positives and negatives there. So what happens is that charges can be induced. So when I bring this balloon, which is mostly negatives, near the wall, which is evenly spread out, the fact that the balloon has negatives near the surface here will induce the negatives that were near the surface of the wall to move away. And now this is exaggerated because the negatives in the wall cannot move that far. Okay, they just move to the opposite side of the atoms or the molecules or whatever. But what that means is that the positives are going to be closer to the negatives. The negatives are further away. And so, again, because distance matters, overall there's an attraction between the negatives that are on the surface of the balloon and the positives that are closer to the surface of the wall. And so this is known as induction, and that's how you get attraction of neutral objects. Okay? If they were truly neutral, it wouldn't work. One thing to understand with electricity is that, the difference between conductors and insulators. Conductors are things that allow charge to flow really easily, and insulators do not allow charge to flow, so they impede the motion of charge. And so most commonly we think conductors is pretty much like, well, any metal is going to be a conductor, and anything not metal is oftentimes an insulator. There are some exceptions, and there are things like semi-metals that are semiconductors that conduct under some conditions and not under others. Okay, but we're all pretty familiar with, or maybe not. I guess we'll find out like what sorts of things conduct electricity and what sort of things do not. Okay. So talking about then how objects become charged, there's actually a couple different ways that objects can become charged. One of them is by friction, so by rubbing two things together, and that's probably the way you're most familiar with building up static charge, is that when you have two materials rubbed together, electrons tend to come off of one and go on to the other. And so here I've got what's called the triple electric series, and what this shows is what sort of things like to become positive and what things like to become negative. So for example, when you take and rub human hair, okay, so right here, onto a balloon, and so let's see, where's something that's similar to balloon? Is it not on there? Not seeing rubber. Oh well, let's say it's like the plastic on cling film, okay, even though it's not so much. If you were rubbing human hair with like saran wrap, which is what I'm assuming they mean by cling film, the cling film is more likely to become is going to be negative, and your hair is going to be positive because the film has a stronger affinity towards the electrons than the molecules that make up your hair. The other way is to you can charge things. You can charge by induction. So if here in the diagram we see that we have two uncharged objects. If I bring a negative object close to it, what it does is it attracts, it pushes the electrons away, it leaves positives at the surface, and this one gets negative. And so now in diagram 3, if I pull those two things apart, then the negatives stay where they are. They didn't have a way to get back. And so I'm left with two objects now that have opposite charges. So when you charge by induction, you make objects that now have opposite charges. Okay, so you start out neutral, and the interesting about charging by induction, the charge on A and the charge on B have to be the same because they started out as neutral. So however much charge one went up by, the other one had to go down. You can also charge by conduction. Okay, so if I take something charged like in diagram 1 and I touch it to a conductor, like in diagram 2, some of the charges will go onto the new thing. And that's because charges always want to spread out as much as possible. So since they have like a new place to go, they'll spread out onto it. And then when you release it, it doesn't come back. So that's charging by conduction. When we ground things, okay, so grounding is an important thing in talking about electricity. Basically, you're taking the charge away. And in some ways, grounding is just, you can think about it as charging by conduction. It's just you're discharging by conduction. And the way grounding works is the Earth is generally the way we think of grounding is so large that can accommodate a lot of charges. So let's think about if I had this small sphere and it had 4 charges packed onto it really tightly. If I take that sphere and touch it to the larger sphere, okay, the larger, you can think about that in a way, even if all of 4 of those charges left and went onto the larger sphere, they're not, it leaves, if you're evenly spreading out all those charges, on average, you're not really leaving any charges on the smaller sphere. So you can think of the smaller sphere just basically lost all of its charge. And when we ground things and connect to the Earth is so much bigger than everything else we're touching, that we're going to be talking about, that the Earth can take that charge very easily because it can spread out so much that, again, it doesn't change, like, in a way, how charged, they can think of it, or how strongly the charges are pushing on the Earth, and so that you can just take it right in. And so that's how grounding works, is just giving a lot of area for that charge to spread out on. Okay? All right, so those are all the concepts that we have, just not too much to start off with static electricity. There's tons of things about static electricity that we could learn, but we'll save those for more advanced classes.